One of the things we really had to do to launch the whole field of X-ray astronomy in general was to get up beyond the atmosphere. So Chandra was launched into space in 1999 aboard the Space Shuttle Columbia. And Chandra represents not only those achievements of launching outside of the atmosphere, but also fundamentally changed how we view the universe and what we understand about it. So tonight, we are really fortunate to have a panel of experts to tell you all about it.
In order to actually generate X-rays, you have to have medium which is very, very hot. So you somehow have to heat up the matter and the gas to very high temperatures, million degrees. And if you observe X-rays, you know that something happened in space that heat up this medium to very high temperatures. And when we detect X-rays, we can trace it back to the physics of the object we're studying and understand what was happening.
X-ray telescopes actually do work off reflection, but at very shallow angles. If you come into a very smooth surface, you can reflect X-rays. And so now if the surface is shaped properly, you can focus X-rays down onto X-ray detectors. And the Chandra optics are so good that they focus incoming X-rays into an image whose size is the width of a human hair.
So Ricardo and I wrote a proposal to start a study in 1976, and in 1977 Martin moved down here to Marshall, and Marshall and the Smithsonian started working together. It's now 23 plus 19, 42 years we've been working together on this project. It's an amazing team.
In my case, in the position of a shuttle commander, I had to depend on my crew. It was such a team effort. Yeah, so this was a very different payload. It filled up the entire payload bay. And I even remember John Young, you remember astronaut John Young, who flew Apollo 16. He had been the chief of the astronaut office for a while. He was very concerned about the amount of clearance with the back of the IUS. So we had inertial upper stage, as you know, which took Chandra up to its higher orbit. When you tilted the Chandra up prior to deploying it, I think it might have been a 6-inch clearance or something. It was very, very close. That was one of the big challenges I remember. And another is the weight of Chandra, which I'm told is the heaviest payload that has ever flown on a shuttle. With the Chandra mission, we had more black zones, which were zones that were not survivable for the crew because of the amount of weight. You couldn't just punch out the payload like you can in the Air Force. You would just, drop the payload and you bring the airplane back, but that's not an option in the shuttle. 5 seconds after liftoff, we had, in the cabin, we had a tone. What had happened was we lost AC-1 Phase A electrical bus, just momentarily. We had lost a controller on our center engine and another controller on our right engine. One more failure would have meant an engine out. That didn't happen. The other thing that happened was right at liftoff, a pin, this is a completely separate failure, a pin came out of the injector plate in the center engine and it hit the nozzle extensions. The tubes that you see in the engines recycle the cold hydrogen for thermal conditioning. Well, the pin opened up 3 of those tubes and we leaked hydrogen all the way to orbit. We shut down engines based on the fact that we ran out of gas. But the key thing was we had a perfect, absolutely perfect Chandra deploy. Nothing happened on that at all.
Thank goodness.
It was almost boring.
I think the biggest discovery of Chandra, at least in my eyes, is the direct evidence for dark matter. The big event which happened between 2 clusters of galaxies. At some point in the past, these 2 galaxies merge, and we can look at the gas which is heated, so hot gas in these 2 clusters, and compare the location of this hot gas to actually the location of the gravity, the central gravity of these clusters. And you can see that there is a displacement between the center of gravity and the location of this cluster gas. And this displacement, it's really telling you that there is the dark matter there. There is no question about it.
A number of us here at Marshall, at SAO, MIT, Penn State, Goddard, have been working on a mission called LYNX, LYNX, the cat with very sharp vision. It would have comparable imaging power, so the images would be just as sharp, but we would collect 100 times more X-rays in a given amount of time. We do it by making the mirrors very, very thin. We'll be seeing 10 times further out in the universe. We'll be able to see things that are 100 times weaker.
And what Chandra can do, LYNX will do so much more powerfully and better. Far better energy resolution, as Harvey mentioned, because the detectors have the ability to determine the energy with extraordinarily high precision, even if the amount of X-rays coming from the objects are very faint.
I think about what our young people are learning today about the universe, and I think, part of Chandra's legacy will be, inspiring young people to choose these degrees in science, maybe not astronomy, but, something that would contribute to astronomy, whether it's, designing these future missions or, joining the space program in some way, being inspired by, this beautiful universe that we live in, and getting their curiosity to the point where they want to keep learning more and more. We're in such a wonderful period of renaissance right now in astronomy. It just makes me want to live for hundreds of years so I can keep learning more.
Chandra has really revolutionized not only how we see the universe, but how we understand the universe. So the X-ray universe is yours to discover. I hope you take advantage of that. Can we thank the panelists for joining us tonight? Thank you.